Hello guys, welcome to the course of TCP/IP. Today we are going to discuss about the QoS. That QoS stand for Quality of Service. So what the quality of service it is, what are the parameters are available, why the quality of service is required, and how it is gradually moving from low to high. So that is what we are going to discuss. And this quality of service is very important for the real-time communication, real-time audio, video, and the multimedia kind of thing. So let's start with the quality of service, guys. So here, if you go with the traditional methodology, the quality of services is what the QoS. It is a description or a measurement of overall performance of services, such as a computer network service, particularly the performance seen by the users of the network. So our concern is what the network, and if let's say we have a network, and that network is providing some services, and that network performance can be analyzed on the basis of the parameter and how that networks perform. That quality parameters can be important to measure the performance of the network, guys. So I can say in simple word, if I have a network, and if somebody says, let's say my network is very reliable, my network is very powerful, my network is very fast. So these kind of parameters are going to be analyze that particular network performance. In second word, the quality of service technologies accomplish this by providing differentiated handling and capacity allocation to specific flow in the network traffic. So here the second term is what the flow, that is what the data flow. So in order to handle that data, in order to handle that packets, that network must provide some kind of mechanism so that that flow can be never can be lost, never can be damaged, and can be reached to the destination. This enable the network administrator to assign the order in which the packets are handled. So what we have two methodologies: connectionless, connection oriented, where the packets can be independent, packets can be dependent. Okay, in the amount of bandwidth afforded to that application or the traffic flow. So here the bandwidth kind of things also can be very important. Now, the quantitatively measure quality of services, several related aspects of the network services are often considered, such as like a loss, bit rate, throughput, transmission delay, availability, jitter, packet loss. Many of the parameters are available, guys. Okay, and that parameters measure the quality of that service, quality of that network. Then quality of service can be applied to the both textual data and the multimedia data. But if we talked about the textual and the multimedia data, the gravity and the precedence are different. It is more an issue when we are dealing with the multimedia. So if you are multimedia and the real-time communication, so quality of service is supposed to be very high, I can say. And in textual data, it can be tolerant up to some extent, not at all, but not up to larger extent, but it's up to some extent. The quality must be improved, enhanced each time for the real-time application. So for example, if let's say if I have average or fair amount of quality, I need to be uh, improve that quality to be in the position of the better. If I have a better quality, it's supposed to be go to the good quality. If I have a good quality, I supposed to go to the very good quality, guys. If we have a very good quality, I again we need to go to the excellent. And if I have excellent, then I again need to go to the best quality. So in this graduation is called as what the quality of service, where the quality of service each time supposed to be improved so that others can rely on our service. So I hope guys that you understand the definition of quality of service, where the quality of service supposed to be an incremental, okay, of any kind of things. So let's take what are the parameters are available with the quality of services, guys. So there are some characteristics like a packet loss, reliability, delay, response time, jitter, bandwidth. So let's take one by one over here so that we can measure the quality of service thoroughly. Very first parameter of what we have taken over here, the packet loss. What the packet loss? The packet loss happened when the network link becomes congested. So congestion is what? There are too many packets are transferred from one path, the congestion can be occur. And the router and the switches start dropping packets. So ultimately routers or maybe the switches can drop that packet, can drop the packet because the congestion occurs. Let's say if I have only 10 carrying capacity or 10 flowing capacity of that particular network, and I'm sending the 50 packets. So ultimately, only 10 can be live and other can be discarded. And the congestion occur, other can be discarded by the packet, by the routers or the switches. When the packets are dropped during the real-time communication, such as video or voice and video calls. This session can expire jitter and gaps in speech. What we have, we used to have this scenario where we are, let's say, watching the live streaming live cricket match, where if our signal is very poor, what there will be loss of packets. So at the time the image is not going to be fully cleared, let's say like a blur category, or let's say maybe corrupted categories will be there. So this happens upon what kind of application it is. So for the real time application, it is going to be never supposed to be packet loss supposed to be very low. I mean to say that is packet loss not at all supposed to be there. So packet loss is what very good parameter. On the basis of that, the quality of service can be analyzed. Second will be reliability. Once the packet loss happen, if when any network is providing a much packet loss, so no one can rely on that network. So reliability is what who reliability is what the reliability is the characteristics of the flow needs. So in order to flow that particular datagrams, we required reliability. How it is going to happen? Lack of reliability means the losing packet or acknowledgement. So packets can be lost and acknowledgement can be lost, which entails retransmission. Retransmission again can be done. Okay, again if the retransmission done, then again the confliction or maybe the congestion can be occur more. So again the loss of packets will be there, and again the loss of acknowledgement will be there. So this is what the cycling mode. However, the sensitivity of application program to reliability is not the same. It depends upon what the categories of application it is. For example, it is more important in electronics mail, file transfer, and internet access have the reliability transmission, that telephone or audio conferencing. So overall, the reliability is what the one can rely on our network. How it can rely on the network? If there is a very low packet loss, if there is a no any loss of acknowledgement, if there is a less retransmission happen, if there is a everything is going to be very smooth and fair, then others can rely. So this is what another parameter on which the quality of service can be improved, the reliability. Next will be the response time. The response time is a measure of the total elapsed time between the start and completion of task. The general definition: start and completion start. Let's say sender and the receiver. Starting with the sender and ending with the receiver. On the internet, for example, let's say response time would be the time it takes after user hits the enter key and the requested web page is displayed on the browser. What we have taken over here, the example of the browser. We are searching some content on the internet and we have typed something. Once we have hit the key of the keyboard, from that time to the first response getting from us that the some content will be appear in front of us. That is what the response time. So this if that response time is supposed to be again low. If the response time low, that time what one can rely, and one can the packet loss also will be very less. So this is what the third parameter of the quality of service, that is what the response time, and response time is supposed to be very low. Next will be the quality of service parameter is what the delay. Network delay refer to the amount of time it takes of packets to go from point A to point B. If the point A is the source and point B is the destination, then the delay is called as end-to-end delay. So what is the delay? It is what the latency we can extra time or additional time required to send from one end to another end is what the network delay. Again, in the application can tolerate the delay at the different degrees. The delay can be at the different degrees, but it should be close to the zero as possible. Delay is supposed to be close to be zero. In this case of, let's say, telephony, audio conferencing, video conferencing, and the remote login need the minimum delay, while the delay in the file transfer and email is less important. So if we are performing the logging, video conferencing, audio conferencing, the delay is supposed to be zero. But if you are sending the email and any file transfer, that time delay can be tolerated. A delay can be vary. This is what example. And there are some types of delays are available, guys. And the better the definition for it. Say if I'm sending the packet for the T0 time, it's supposed to be get for the T2 time or T1 time. So there is a no delay. Okay, so I'm doing action at the one tick o'clock, and at the second tick o'clock what we are getting the response, no delay. But if I'm adding, let's say, instead of it receiving the at T1 time, it is receiving at the T2 T3 time. So here we are getting some delay, we are getting some delay response. Okay, there are some types of delays are available. Very first is a propagation delay. Propagation delay is the time that it takes for a bit to reach from one end to the one end of the link to the other end. This is what the propagation delay. From one end to another end, whatever the time elapsed, that is what the propagation delay. Transmission time. Transmission delay refers to the time it takes on the transmit a data packet onto an outgoing link. On that particular link, let's say there is a link. On this link, what transmission time required, the delay is determined by the size of the packet and the capacity of the outgoing link. So transmission delay is depend upon what this capacity of the link it is and what the size of the data it is. So that amount of time required to transfer any packet from the one end to another end, that is what the transmission delay. Then next will be the queuing delay. The queuing delay refer to the time that packet waits to process in the buffer of the switch. The delay is dependent on the arrival rate of the incoming packets and transmission capacity of the outgoing links and the nature of the network traffic also. So let's say if I having the sender and the receiver, and but there is, let's say, buffer, and here the sender there are so many of sender. Let's say sender 1, sender 2, sender 3. So if sender 1 is sending, sender 2 is sender 3 is also sending, though at one time all the packets cannot be processed. But here in this buffer, the sender 1 packet, sender 2 packet, sender 3 packet will be stored. And whatever the amount of time is waiting over in this queue, that will be queuing delay, because at a time all three cannot be accepted by the receiver. So here, as good as, let's say, if we are going to the submission of any form, so we are forming the queue, and we are getting the only chance when our numbers allocated. So first will be first in first out, second will be second in second out, third will be third in third out. So it is what the queuing delay, guys. Okay, and the fourth is what the processing delay. The processing delay is the time taken by the switch to process the packet header, and the delay depend upon what the processing speed of the switch, the switch or maybe the router. It can be switch or maybe router. So in order to process that header format, to understand that header format, what is mentioning, whether it is a version 4, version 5, what it message it is, what kind of fields are filled, that understanding is called a processing delay, guys. So by combining this, all the delay is what the total delay: propagation delay, transmission delay, queuing delay, and processing delay. Combining this, what the network delay we can say. Okay, so it depend upon what processing delay. It depend upon what the number of fields are available and how that fields are filled, have filled. Okay, so this is what the delay terminology. Next point is what the jitter. Next is what jitter and bandwidth over here. So jitter is what the variation in delay of packets belonging to the same flow. Let's take an example. If we have a 4 packet depart at the time 0, 1, 2, 3, and it arrived from 20, 21, 22, 23, all having the same delay of the 20 units of each. So here the delay is fixed. If we talked about, let's take the second example. On the other hand, if we above 4 packets arrive at the 21, 23, 21, 28, there will be different delay. So initially it was the 20 unit fixed delay. Now it is different delay, and these variations of delay is called as jitter, guys. Variations of delay is called as what? Jitter. For the applications such as audio and video, the first case is completely acceptable, and second case is not acceptable. Okay, so variation of delay is not acceptable. That is what the jitter. The high jitter means the differences between the delay is large, and the low jitter means the variation is small. So I can give you the example, guys. Let's say if I have a student which coming to the college. Let's say college timing is, let's say, 10 o'clock. Okay, so student is coming to the college on the day one, let's say day one on the 10 o'clock. There is no delay, there is no jitter. The same student on the day 2 is coming to the college by 10:05. On day 3, it is coming to the college by 10:10. And day 4 again, it is coming to the college by 10, let's say 6. So here 6-minute delay, here 10-minute delay, here 5 minutes delay. These variations of delay is called as what? The jitter. I hope it is understood by you. Then second term, so delay is supposed to be jitter is supposed to be again minimum variations. It's supposed to be zero, but it's supposed to be null, but it's supposed to be we can say it can be tolerated up to minimum. Then bandwidth. What the bandwidth it is? It is a capacity of network communication link to transmit the maximum amount of data from one point to another in the given amount of time. We can say it must be bandwidth supposed to be high. It is what the carrying capacity, what amount of data can be transferred from one end to another end. For the video conferencing, we need to send the millions of bits per second. To replace a color screen, while the total number of bits in the email may not reach even a millions. So what we can see, the bandwidth is what the carrying capacity, guys. So larger bandwidth, so more speed, lesser bandwidth, the less speeds. So bandwidth supposed to be again high so that the packet loss speed will be very high, packet loss will be very low. If the packet loss is very low, then one can rely on the network, so reliability can be happen. If the reliability more, why it is reliability more? Because the delay and jitter can also be very low. So total terminologies depend upon what the bandwidth is. If the bandwidth is very good, then other parameters can be diluted. The speed is more, delay will be never, jitter will be never, response time will be very low. These terms are depend upon what the bandwidth is. So this is also another parameter of the quality of service. I hope guys the quality of service is okay with you, because quality of service is what the parameters available with us. Regarding that, let's say we are talking about the networking. So network parameters are available on the basis of that parameter. What we are measuring the capacity of the network, where we have discussed the bandwidth, delay, jitter, response time, packet loss. All the things are available. So to improve this, what we have the techniques. What techniques? Scheduling techniques are available, traffic shaping is available, admission control and the resource reservation techniques are available. So these all the four techniques having the separate existence. I will be giving over here only the definition of this all the four, because this is what the part of simple computer network. This is not the part of a real-time network on this syllabus. The scheduling. What happened with the scheduling? Packets from the different flow arrive at the which switch and the router for the processing. So good scheduling techniques treat with the different flow in the fair and appropriate manner. So what about, let's say if we have a proper arrangement of any request, so there will be a quality of service parameter will be good. So let's say FIFO, first in first out. Let's say priority queuing, let's say weighted fair queuing. Okay, so these are the three scheduling criteria are available. In each scheduling criteria, what happened with the weighted queue? The better scheduling method is weighted fair queue. In this technique, the packets are still assigned to the different classes and admitted to the different queues. So here there are different queues are available. The priority queues packets are first assigned to the priority class. Then each priority class have its own queue, so separate queues are available. So there will be no kind of response time will be very low, we can say. And the packet in the highest priority queue are processed first, and lower priority queue the process last. So this is priority queue, and first in first out, the one which reached the first will be processed first. So these are the three scheduling criteria are available. I'm going quickly because this is not part of our syllabus. Then the traffic shaping. What we have discussed traffic shaping for what purpose? Traffic shaping is the mechanism to control amount and the rate of the traffic sent on the network. There are two methods are available. So in order to maintain the traffic and in order to handle the traffic, what we have traffic shaping, what we have the leaky bucket and token bucket. What we have seen in, let's say we have a bucket and bucket having a small hole, and bucket is also having the input. What the input is there, input, if the same type of input is there and the hole is also same, the outlet will be same. But if the input is very large and my outlet is very low, so there will be choke. The overflow will be there. The overflow will be there. There are two techniques, leaky bucket and token bucket. What we have, the leaky bucket algorithm is token independent, where the token bucket is what dependent. Leaky bucket algorithm, when bucket is full, the data and the packets are discarded. But in the token bucket, if the bucket is full, the tokens are discarded, not packets. So packets are not discarded over here. Leaky bucket send the packet at the constant rate. The rate is constant over in leaky bucket, but here the packet rate is faster rate. Okay. Then leaky bucket algorithm, packets are transmitted continuously, but here the bucket packets transmitted when there is enough tokens available. So here token mechanism. So this methodology is very good mechanism where token is assigned to everybody, and on the basis of the token, the flow can be there. Next will be it does not save any token, does not save any token, but here it save the token for the burst of the packet transmission, and the leaky bucket algorithm is more restrictive as compared to the token bucket algorithm, whereas the token bucket algorithm is less restrictive as compared to the leaky bucket algorithm. So these are the few points related with the traffic shaping, guys, where the flow can be maintained on the basis of the the mechanism of leaky bucket and the token bucket. There is a third method, that is what the resource reservation. What happened with the resource reservation? The flow of the data needs resource such as buffer, bandwidth, CPU time, and so on. The quality of service is improved if the resources are reserved earlier or before. So all the provision is made earlier. That is, prevention is better than cure line kind of things. So that is what the reservation of the resources. If the resources are reserved earlier, there will be no kind of any other degraded quality performance will be there. So quality of service model called integrated service, which depends heavily on the resource reservation to improve the quality of service. So earlier, all the resources are made available. So if the earlier all the resources are available, so speed will be high, response time will be low, bandwidth will be high, CPU time is also more. So that network capacity will be very high, and anyone can rely on that network. And there is a last method, guys, that admission control. This admission control refer to the mechanism used by the router or the switch to accept or reject the flow based on the predefined parameters called the flow specification. So which packet to be accepted and which packet to be rejected, it depends upon what the admission control policies. Before the router accept the flow of processing, it checks the flow specification to see if its capacity in terms of the bandwidth, buffer size, CPU, and speed, and its previous commitments to the other flow and handle the same new flow. If you have any, let's say, recruitment kind of things, we always check the past history, past experience. On the basis of that, only we can admit that particular person to that particular industry. So here, the same, that router and switch will check whether that flow is going to be accepted or not. So on the basis of some parameters, if the parameters, quality parameters have been good, then only it is going to be accepted. So what we have discussed, quality of parameter, guys, the quality of service, whereas we have discussed packet loss, delay, jitter, latency, and other parameters, also reliability. And after that, we have discussed about what are the methodologies available to understand that particular things. So here, the moreover, there is one questions available in the Nagpur University, guys, for the quality of service. So for the 4 to 8 marks. So this is all about the quality of service, and the quality of service depend upon what the application to application. I hope it is okay. Thank you. Thank you.